almost there. Okay, we are on air now. So let's
Okay.
start.
Lesson 10, group meeting quiz. Yeah, I mean, Moses, I certainly can understand that it'd be easier to, or feel more prepared if we met twice a week.
Yeah.
I wouldn't do that. I'm not gonna be able to.
So, what do you guys think?
I really don't care. It's just this is late. 9 o'clock is late for me. So to be 10 o'clock or later, I'm not gonna be able to do that. And I don't mind doing it on Tuesday and Thursday, just as long as we're just meeting right at 9. For me, I don't know. I'm just saying what mine is. I don't know what you guys' is.
Yeah, Thursdays are okay for me at after 8:30, because at 8 I have a really short meeting, 20 minutes meeting, and then I'm free after that. Oh, wait.
What about Wednesdays?
Okay, how about we talk about this at the end? We just start thinking, and because we are recording.
All right. Sounds good.
That I'm meeting with, but okay.
Okay, so find the margin of error for 90% Okay, so the first two are just the ones that we just answered to our own whatever's for us. And then number 3 is find the margin of error, which is z times the standard deviation over the square root of the sample number. And so find the margin error for 90%, and the margin error for 90% was 1.96 times.
Yeah, that's the formula, right? That's on the reading.
Yes. 50 over the square root of 25.
Yeah.
So 50 divided by the square root of 25 is 10. And then you're going to times that by 1.96. And you get
1.96. That's 95. Isn't it the 90%? Which is 1.
Oh, yeah. Sorry. Yes. 16.450. Yes, sorry. That's what I did on the first test, and that's what I got it wrong. So 10 times the 1.645, and so it's 6, and then you're supposed to round to 3 decimal places. So then 16.450, is that right?
16.50.
450, yeah. And
yeah, because it's 3 decimals, right?
Yes. 1.645. And then which of the following statements are true? I've never even seen standard deviation squared on anything.
I think I saw this somewhere. That X is a point estimator of U.
That's what I think too. Yeah.
Is that true? Is that correct?
The X bar is going to be the estimator for the new.
Yeah.
Now that we're doing the T-score, we're doing an X bar.
Okay.
And then Gina wants to construct a 95% confidence interval for the GMAT score. She knows that the standard deviation is 113. Oh, hold on. I wrote, okay. The standard deviation is 113. She collects a random sample of the size of 64 and computes the X bar to be 526. So use the information for the next 6 questions. So our X bar is now our mean. So what is the point estimate? And that is what the X bar is.
It's 526 or
yeah. The X bar is the new point of estimate or whatever.
Uh-huh.
Mhm.
And the
Margin of error is the 1.96, right? 0.
yep,
Or
time times the 113 over the square root of 64. So it's 14.125 times. What'd you get?
1.96 times the square root of 64.
No.
No.
It's 196 times 113 divided by
The square root
of 64. Yeah.
Uh-huh. So are we working on number 5 or number 6?
We are on. Hold on, let me put in my answer.
26.
That's number 6.
Oh, okay. I'm sorry, my computer kind of freezes and yeah, 95% confidence score.
Number 6. 27.685.
Yep, that's what I get too. Do you guys understand how we got that, Moses and Katie?
I'm kind of trying to follow in the formula, but so it said
so if you look at the problem,
so we're working yes, so go ahead.
If you look at the problem, Katie, on just above number 5, so she's there. We know that the standard mean or the standard deviation is going to be 113. The sample size is 64, and then the X bar or the mean is 526. So we don't need the 526. Yes. That's number 5. Number 6, they want to know what's the formula that we're going to use, and we want to do it for a 95%. So
there's a formula, so that amount has to be in both sides of the formula, right?
So the Z is going to be 1.96. And then you're going to times that by the 113 over the square root of 64.
Of 64, yes.
So then I go in there and I do 113 divided by the square root of 64, and I get 14.125. Right. Did you get that?
Yeah.
And then you're going to times that by the 1.96, which is the 95% level of confidence. And so you're going to get 27.685.
685.
27.685. Okay.
Yes.
And then what is the lower level of this confidence interval? So now you're going to take the mean, which was the 526, and you're going to minus it by subtract it by the 27.685. And then you want to round. Go ahead.
498.15.
685. 498.685.
Where are you getting 0.685? If you subtract 526.
I'm sorry.
Subtract
7.685
from 526, so the answer is 498.315.
Yes, that's what I meant. Yep. Sorry, I gave you the upper level. The next one is the upper level.
The upper level is the 526 plus the 27.685. Yeah.
Yes, that was the 685 that I was getting mixed up. I'm sorry, 553.685.
Yes.
And then what happens?
It's just following the formula, right?
Yeah. Now you're just adding or subtracting the mean from the numbers that we already figured out, the margin of error.
Yeah.
And then what happens to the width of the confidence interval as it increases in the sample size?
It would decrease.
Yeah, I think
Decrease?
so.
Decrease?
Yes.
Yeah. Increase the sample size, then the confidence level, like the little bar, the bell would
yeah.
It would decrease.
Because it's getting closer and closer to the z-score, to the whatever it's supposed to be getting closer to, whatever the median is or whatever. The higher you get. Number 10, what would happen to the width of the confidence interval if Gina changed it to a 99% confidence interval?
That will increase or no? Or
yes, you're right. And then this one was ridiculous. This one was absolutely ridiculous, and I did not realize that we had a formula for this until I started doing it. Oh my God.
You already got your margin of error, so you put the 50 equals the z-score over, or the z-score times 400 divided by n. You solve for n, right?
Yes. Did you know we had a formula to solve for n, though? I didn't know that until about half an hour into this stupid thing.
We have a bunch of formulas for this week. That's so many.
Well, the formula is here. I mean, yes, their formula I've written down here. However, it's basic algebraic stuff. So all you need to remember is the margin of error, and then just solve for n. Which, if you solve for n, it gets you the n equals parentheses z-score times the standard deviation over m, and that whole thing squared, right? That's your formula. But if you just solve for n, you know, with the regular margin for error, that you'll get to that formula.
Okay, that was too complex for me.
So
yeah. I just know what the I started the long way and subtracted and divided and multiplied and everything until I got to that. What you just gave me was the n equals parentheses. I had no idea that's what that was.
Yeah, just solving for n.
You did the best math. This is a formula, and it's like 4 or 5 things you need to follow to get the answer, right?
Well, I don't know if you can see this, but if you take if you write m, if you do the margin of error formula, which is m equals z-score with the little asterisk times the standard deviation over the square root of n, right? That's the margin of error formula. So in order to solve for n, what would you have to do there? You're going to multiply the square root of n on both sides.
Yes.
And then you're going to, in order to get rid of the m on that side, you're going to have to divide by m. And then in order to get rid of the square root, you're going to have, or the square root thing, you're going to have to take the square root of the other, you know, parentheses, square root them all. And then you've got n by itself. It's just algebra is all you're doing. So yes, there is a formula, but if you understand just regular algebra, you can get there super easy.
All right, it's super easy for you. It's not super easy for me. I did not get that super easy at all. I sat down with the tutor and she did exactly what Lance just told me. And then I found out that we already had a formula for it and I didn't have to do all that work.
Yeah.
It was, yeah, I was kind of taken back. Anyway, so then if we're going to solve for n, then we're going to do the z, which is the 1.96, right?
1.96, yep.
Times the standard deviation, which is going to be 400. Divide that by the 50.
50 hours.
And then we're going to square all of that. And Lance, so maybe you understand algebra better than I do. See, when I was figuring this out myself without having to Google it to help me solve it, I was doing 196 times 400 and then dividing it by 50. And then I was doing the square root and I wasn't getting that. They want you to put the 1.96 times 400. They want you to square that first.
Or parentheses, maybe?
You know what? I don't know. That's why I was asking. If he understands algebra, then why can't, what's the difference?
Say that again.
Okay. So so just if you're doing on your calculator and you do 1.96 and you do that times 400, that gives me,
and then divide that.
And then you do, so I get 784, and then I'm going to divide that by 50. Wait. 784 divided by 50, and I'm going to get 15.68, and then I'm going to square that, and that's going to give me, oh, well, no, now it does it just fine.
245.862.
Yeah. All right, it wasn't doing that for me earlier. And this
245.862 should be our answer, right?
No, I got it wrong. Look at the bottom. It says round it to the nearest whole number.
Okay, so 246.
So yes, 246.
Yes, I got it wrong because I didn't round it to the whole number.
Oh, yeah. You see those things that I think that happened to me in the exam. It's like rounded was always my problem. I don't know if it's over 5, you have to round it to the next number, or if it's less to the other number before. But sometimes it's just, I think I don't read very well. I don't understand it.
So these remind you, if you see that.
I know.
I think all we really need to know for this little section, I've got notes. I mean, yeah.
Did you find that on the lesson?
Well, yeah, I read the lesson and watched the videos, and for some reason, this section kind of made more sense to me. But I've got a much better grasp on the whole z-score and all the other stuff from before. It's just it finally kind of started to click for me.
Oh, the margin error, right? I don't know if it's this. Let me share the and
having a graphing calculator finally helps, so I'm not having
is this one, Lance? Is this a formula that you're talking about?
No. That's not the formula.
It's not.
It's missing the parentheses.
Yeah, that's in the other. That's not the exact formula. The one you want is where it says where there's a sample and it says, where you can click on the thing, show me the math or whatever, show you the math. And then it's
kind of show the solution.
Yeah, show the solution area thing. It's going to be further down. It was towards the end when it started to solve for n.
Is here.
that's when it was like solving for n. I'm like, well,
okay, that's we can mean.
It's just algebra.
Yeah.
Because I can just look at it in the word problem to me. Okay, so it gives me the margin of error, gives me the standard deviation, it gives us the confidence level, gives us everything but n. So then all you do is just solve for n. And so then you can do the regular algebraic steps and you get there. Pauline's correct, though. They do have a formula. You can kind of bypass those other steps. You get there either way.
Yeah.
Okay, so we want to figure out the margin of error for the next one.
Uh-huh.
The $100,000 whatever. Number 12. We know that the mean is 100,000. The standard deviation is a 36,730. And then our
30 is 36.
the level of significance that we're trying to prove is 0.05, and we're going to have a sample size of 36 people, and we're trying to prove the one for 111,000 at 95% confidence interval.
Mm-hmm.
So we're going to do 1.96 times the 36,730 divided by the square root of 36. And then take that answer and times it by 1.96.
1.96 times 36,730 divided by the square root of 36. And that gives you
21 times 1.96. And we get 11,998. And then on this one, for the 95%, they're wanting to know the lower limit of it. So we would do the 100,000 minus
11,009. 467
minus 100. 88,001. And you want to do it to the whole number because I missed that.
Okay, say again. Once you're at 11,998.467.
So that's the margin of error. So now you subtract that from what the mean of 100,000 is. This is where you're going to plus or minus it to find the upper and the lower level.
You subtract 100,000. You subtract 11,998 from 100,000, right?
Yes. And then he wants it in a whole number.
So you get the 88,002.
I don't know myself. It's like something is going on with this. It's just the whole day is having me. I'm having this problem. I'm just working
so that's
on
the lower limit is
or
the 88,002.
And I think.
And then the upper limit would be the 111,998
or 112,000. He wants it in a whole number. So I'm thinking he wants 88,000 on the first one and 112,000 on the second one.
8802 a whole number, and isn't 11,998 a whole number? It's not saying round to the nearest 10 or the whole number is just no decimal point.
I don't know. I put 111,998 and I didn't get any points.
You did 11.
I think he wants 112, but I'm not positive. And I think he wants 88, but I'm not positive. I missed both of those.
So we are going to get the upper limit, right? Like similar to the other one we did before.
Yes. Yeah, you add the 11,998 to the 100,000 and then you subtract it.
Hey, isn't it 111? Isn't the X bar the new mean, not 100,000?
Oh, you know what?
It's 100,000, right?
It'd be 111,000 plus or minus the 11,998, I think.
You know what? That might be why I got it wrong, because I was taking it away from, I don't know. I already took the quiz and missed it once. So I don't know if somebody wants to put it in there and subtract the 998 from the 111,000.
I think it's 122,998 for the upper, and then it's the lower is 99,002. That's what I'm going to put. I think because isn't that X, the X bar is the new mean based off of that sample.
Yes.
So it, even though the real mean is 100, we're going off of the sample, which with that one, it says that the new mean is 111,000.
That sounds.
I'm going to put 9902 or as my answer for 12.
00002.
Yeah, and then my answer for 13, I'm going to put 122,998.
Okay, we can try with that. So it's not 12 that Pauline did.
Because that's a whole number.
Yeah, you're right, it is. I just missed it when I put those other numbers in there and I didn't know why, but that would make sense.
Uh-huh.
And then there are 3 requirements that need to be checked when computing a confidence interval for a mean.
Yes, the number 1 it is.
Number 2's right.
All of the above, I think. Uh-huh.
Wait, what did are we on 14?
We're on the last one.
Yeah.
We know the standard deviation is known. The simple random sample was drawn from the.
I think it's all of them.
I think so.
Yeah, me too.
Okay, I'm gonna submit and see what it did. Got 100%.
Okay. So we are right.
And our group times are getting shorter too.
You get smart every week, guys.
This one I actually understood. Wait until you guys jump on the next one. If you guys can understand it, somebody needs to tutor me because I do not understand it.
It's just kind of, some of them are kind of just follow the right formula, I think.
Hey, if we meet tomorrow, I can meet tomorrow.
Okay, let me stop the transmission, okay?
Yeah, let's stop the transmission and then figure